Hi guys, so today I'm going to show you the titration of hydrogen peroxide using potassium permanganate, and ultimately the goal being for us to find the mass percentage of hydrogen peroxide in a commercially available bottle of hydrogen peroxide. And so this is just the hydrogen peroxide that you would go to the drugstore and purchase. And so we're going to find out how much hydrogen peroxide is in that bottle. And so that is our goal. Okay, so we just transferred it from the drugstore bottle to these squirt bottles, and then we put the label on them. Okay, we are going to ultimately perform this experiment using this balanced chemical reaction. This is a redox reaction, meaning reduction and oxidation. And so look, we can see that 5 moles of our hydrogen peroxide reacts with 2 moles of potassium permanganate in the presence of an acid catalyst to produce 2 moles of the manganese cation, 8 moles of water, and 5 moles of oxygen gas. Okay. Notice, guys, that in my balanced reaction, I do not have a potassium cation. Okay, even though we will be using potassium permanganate, which is this gorgeous purple color. You can see what he looks like. He is beautiful. I love working with it, even though it makes a mess. Okay, I do not have potassium anywhere in the reaction. It absolutely, guys, is in the solution. We did not just magically omit it, okay, but we did omit it from the balanced reaction. And we're able to do that just because it's a spectator. Okay, he's a spectator ion. He has nothing to do with the chemical reaction, and we're perfectly okay omitting it from it. Okay, so the background for this reaction, guys, is that we're starting with this purple permanganate, okay, and when it reacts with hydrogen peroxide, it creates a perfectly colorless product. Okay, as long as there's hydrogen peroxide in our reaction, the purple permanganate will react and will form a colorless product. As soon as we've completely consumed our hydrogen peroxide, that purple color will remain. Okay, so once we see the purple color remain, we know we have consumed all of the hydrogen peroxide and we have reached our endpoint of the titration. Okay, so it's very similar to when you did the vinegar lab, where you titrated until you reached the endpoint where you consumed all of the vinegar and the pink color from the phenolphthalein remained. Okay. So to do this experiment, guys, what do we need? We need a 0.100 molar concentration solution of the potassium permanganate, and like I said, it's this beautiful purple solution. And that solution, guys, I already have filled up in my 50 milliliter burette. Okay, you can see it's very dark and he's got it filled up. I also have some backup in this squirt bottle just to kind of keep the mess at bay, but it's still messy. Okay, I also have a squirt bottle of 2 molar sulfuric acid, and guys, sulfuric acid is a strong acid, so we always have to be careful when we're working with it. I also have a squirt bottle of deionized water, and you'll see as I'm doing my titration why I need him. Okay, like I said, I have my squirt bottle of my hydrogen peroxide with concentration of unknown, which we will eventually figure out. I have an Erlenmeyer flask, and this flask, guys, is where I'm going to do my reaction. So my hydrogen peroxide solution is going to end up here, and then I have 2 different size graduated cylinders. Okay, I also have, guys, set up my data sheet, and I've got trial 1, trial 2, and trial 3. Okay, so we're going to start off by putting onto my balance our Erlenmeyer flask, and I'm going to tare my balance to 0, and I am going to weigh into that Erlenmeyer flask roughly 6 grams of the hydrogen peroxide solution. This doesn't have to be exactly 6 grams, so whatever it ends up being, I'm just going to record in my data sheet. Okay, do notice my balance is jumping around a little bit. It's just from draft of the wind, and that little bit of fluctuation is just going to be some error in our calculation, and that's just part of working in a lab. So I overshot 6 grams a little bit, but that is absolutely fine. I'm not worried about that at all. It looks like it settled very well at 6.29 grams. And so that is what I'm going to record on my data sheet for trial 1. Okay. So trial 1, I'm going to do mass of my solution. 6.29 grams. Okay, to this flask, I'm going to add roughly 25 milliliters of my deionized water. This part does not need to be exact. The deionized water has nothing to do with the chemical reaction. It's just there to give you more volume to swirl and facilitate the reaction. So it really does not matter that I'm above the 25. So I'm just going to pour that right into my hydrogen peroxide solution. I am A-okay with that. And I'm not even going to record that in my data sheet because, like I said, it has nothing to do with the reaction. Okay. Also in this flask, we need to add that sulfuric acid. Part of this reaction, guys, is that we need protons. So if we do not add the sulfuric acid, the reaction will not take place and your purple color will persist and you will never get the reaction to do what it's supposed to do. So we have to make sure that we add the sulfuric acid. And we're adding 15 milliliters of the sulfuric acid. He's in a large excess, so again, it does not have to be exactly 15 milliliters. If you're a little over, that is A-okay as well. Roughly at 15 milliliters with the meniscus. So again, I'm going to dump that 15 milliliters right into my Erlenmeyer flask that contained the hydrogen peroxide and the water. Okay, so my reaction flask now contains 6 grams of my hydrogen peroxide solution, 25 milliliters of deionized water, and 15 milliliters of the sulfuric acid solution. This is ready to start the titration. We still need one more piece of data before we can start our titration though. We need to know how much potassium permanganate is starting off in our burette. Okay, so our burette, you can see, has markings every milliliter, but then also markings every 1/10 of a milliliter. Okay, so he is precise to the 1/10 of a milliliter, which means we must record our volume to the 100ths of a milliliter, 2 decimal places. Okay, this is very much important because we always must record using the right precision of the tool that we have in the lab. Okay, so I am super short, so I'm going to have to move our burette down to my level, or maybe I can climb up on a stool. Let me grab a stool. I grabbed a stool and I'm trying to get us up to eye level. Okay. I'm trying to get this so that you guys can see, but it's just going to be very hard for us with the camera to see that dark meniscus. What I know you can see for sure is that the purple permanganate is between 2 and 3 milliliters. Okay, the line of the purple permanganate is definitely above the 3, right? So it's definitely less than 3 milliliters. It's definitely more than 2. Okay. I think right now would be a good point to pause the video and see if you can read the same thing as me. Okay. I'm going to set my phone down and I'm going to read it, not looking in the viewfinder, because that's how I'm reading it right now, and see if I can read it. Well, no, I can read it looking through the viewfinder. Right now, to me, it looks like he's right at 2.89. I'm gonna say that's 2.89 milliliters for my initial volume. Okay, so I'm gonna record that on my chart as volume initial 2.89 milliliters. Okay, now we are ready to go ahead and start adding that purple permanganate to our hydrogen peroxide solution. So since this is my first trial, I'm going to go really quickly, and you guys can see hopefully very clearly as soon as that purple permanganate hits the flask what's happening. You can see the purple color vanishes immediately. Another really important observation is the bubbles. What are those bubbles? Those bubbles are the oxygen gas that are forming. Okay, so I'm gonna let this basically open, and I'm swirling and I'm swirling and I'm swirling. Okay, you guys can see the purple color is disappearing very fast. Okay, it's a very immediate reaction. It's a very cool reaction. It's not really getting hot, just lots of bubbles. Normally I would let one hand control the stopcock and one hand be swirling, but one hand right now is holding my iPhone so I can record the video. See, I've already dropped down below 21 milliliters. So that means I've already added close to 20 milliliters of solution. I happen to know, just from doing this experiment for the last 3 weeks, that means I am getting somewhat close to my endpoint. And I don't know if you just saw that. Probably not, because my stupid hand was in the way. But I was. So instead of just squirting a bunch in now, guys, I'm going a little bit more conservatively and just doing smaller amounts. If you can tell, but that purple color is hanging out longer. Oh, see how long that purple color stuck around that time? I'm gonna try and do single drop. All right, there we go. Okay, so I took it well past the end point, and it just took a couple drops to take it past the end point. I expected to go past the end point because it's my first time, and I'm okay with it. Okay, so you can see the purple color is persisting because we've consumed all of the hydrogen peroxide which means that permanganate is hanging out in the solution. Okay, so I'm at my endpoint, which means I must record the volume on my burette. Okay, and so you can see that the line on the burette is somewhere between 25 and 26 milliliters, much closer to 25 than 26. Okay, now look, between 25.1 and 25.2. Okay, hard to tell, okay, because it's so dark. Okay, I'm gonna read it that it's between 25.1 and 25.2, much closer to 25.2. So I'm gonna say it's 25.18. You might disagree and say it's something else, but we're writing on the same piece of paper, so that's what I'm gonna say, so you're gonna say the same thing. 25.18 mLs. And I'm gonna write that on my sheet as my volume final. Again, guys, it's required that I have 2 decimal points because of my burette's calibrations. He's calibrated to the 10th place, which means we absolutely knew that the 10th place was a 1. We were approximating that 8. Okay, so that 8th place, okay, the 100th place, we had error. We knew that we were guessing that place. Okay, so whether you said it was a 5 or a 2 or a 1 or a 0 or a 9, that was a guess. Okay, and that's where the error comes from, and we're totally okay with that. Okay, so then we would absolutely go ahead and do this for another 1-2 times, and then we would be ready to start doing our calculations. So I'm gonna go ahead and I'm gonna do those 2 off of camera, because it'll be a really long video if I did it on camera. We'll do it off, and then we'll get back together and do the calculations.